We have been looking at solutions to linear equations. Now we want to look at linear inequalities. So let me write one down. Y is greater than 2x plus 1. So note if we had said y equals 2x plus 1, the solution would be, I need to start at 1. The solution would be on these black dots. I start at 1 for my y-intercept, and I go up in a 2-to-1 pattern, or I could drop down and include these points down here on the grid lines. But I don't want this line as part of my solution. The points on the line will actually make the statement y is greater than 2x plus 1 false. So for instance, if I were to take the point 1, 3 and substitute it in for my x and y values, and I write 3 is greater than 2 times 1 plus 1, I get that 3 is greater than 3, which is a false statement. So the line itself, any points on the line, will end up making the inequality false. Now, if this had been y is greater than or equal to 2x plus 1, we would want to include the line, and I would show it as a solid line as opposed to the dashed line that I have shown here. So which points will make this statement true? We can figure this out by what's called guess and check. We can check a single point. So let's go ahead and check the easiest point that we possibly could, which is the origin, 0, 0. So if I put that into the original equation, y is greater than, I should say the original inequality, I would get that 0 is greater than 2 times 0 plus 1, or that 0 is greater than 1. Notice that is a false statement. So 0, 0 is not part of the solution. But that tells us what the solution is. If I take any other point on the same side of the line, for instance, let's take the point 4, 1. Let's see what happens. Substitute into the inequality, we would get that 1 should be greater than 2 times 4 plus 1, or 1 is greater than 9. Clearly false. So no matter what points I pick below the line, in the region that is below the dashed line, they would all return false statements. So we can't include anything below the line. Let's look at the points above the line on the other hand. Let's consider the point 1, 5. And let's come over here and consider y is greater than 2x plus 1. If I substitute 5 in for y and say, is it greater than 2 times 1 plus 1? 5 is clearly greater than 3. So this makes a true statement. And I could take any other point, whether it's on the grid line or not, that is above the line, and I will end up with a true statement. So how do we indicate what the solution is? We can draw the line y equals 2x plus 1 in a dotted fashion or dashed fashion to show that we're not including the line. And then we would include all of the values, or all the coordinate pairs, I should say, that are above the line. And we would not include anything that is below the line. So the region looks like it's above and to the left, but it's better to think of those as being above the line. And here's why. We are, to make the statement true, we have that y is greater than 2x plus 1. Let's consider what happens at a single x value, such as x is equal to 2. When I look at x being equal to 2, if I were on the line, I would be at the point 2, 5. 2, 5 won't make the original statement true because it's on the line. It will return that 5 is greater than 5, which is not true. But any point that is above 2, 5, like 2, 6, will return a true statement, or will make the statement true, I'm sorry. If we put 2, 6 into the original inequality, we'll get that 6 is greater than 5, which is true. But if I try a point below 2, 5, like 2, 4, I'll get a false statement because when I put it into the original inequality, I'll get that 4 is greater than 5, which is a false statement. So for any given x value, all of the y values above the line will make it true. And that's what will happen anytime you have a greater than sign. You're looking for y values that are bigger than 2x plus 1. So y values above the line will make it true. So there are a couple of ways you could approach the problem. The first would be substitute a single point like 0, 0, and see if it makes the statement true or false. If it makes it true, then you want to include all the points on that side of the line. If it makes it false, include the points on the other side of the line. Or simply consider what it means to be greater than, and that would mean you need y values that are higher than the line in order to make the statement true. If this had been a less than statement, we would be looking for y values below the line. Now let's go back to the beginning and consider what happens if I had something in the general form, because it's less obvious what the solution should be. 5x plus 2y is greater than 10. So in order to do a quick plot of this, we can go back and recall that we could substitute in x equals 0 to find the y-intercept. When x equals 0, 2y is greater than 10, or y must be greater than 5. But that means that the linear equation would have had, if I had an equality there, the y-intercept would have been 5. If I substitute in y equals 0, I end up with 5x is greater than 10, or x is greater than 2. So this tells me that I have an x-intercept for the equality that would have been at 2. So I can quickly sketch in a line, and I'm going to put in a dotted line because this inequality does not include points on the line. If there was a greater than equal to sign instead of a greater than sign, then we would include the line and make it solid. Now, given this option, it's not clear whether I should be above the line or below the line. So the point substitution method is the easiest way to figure out what side of the line we want to look at. 0, 0 is the easiest point to select. And if you substitute that into the original inequality, 5 times 0 plus 2 times 0 is greater than 10, gives you that 0 is greater than 10. And clearly this is a false statement. Since it is false, we know that the solution must be the points that are above the line and not the points that are below the line. So we could show that the solution is the region above and to the right of the given line.